have words, when we have words, the first thing we're going to do is write them out in stacked letters, correct? If we don't stack letters, we have no doubling up or tripling letters, which means we won't have a denominator. So, wow, that's large. So we have C, O, R, P, O, R, A, T, I, O, N. So we have the word corporation, just 4, 5, 6, 7, 8, 9, 10, 11. And it says vowels have to be together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. On the bottom, I don't even think about it, I put 3 factorial for the O's, 2 factorial for the R's. Now it says vowels have to be together. 1, 2, 3, 4, 5 vowels. So I'm going to hook the first 5 blanks together. I have 5 options, 4, 3, 2, 1. And then how many letters left? 6, 5, 4, 3, 2, 1. Does it say together at the front? No, so I have to times 5, 7. So I technically have 5 factorial, 7 factorial over 3 factorial, 2 factorial, making sure you put it in brackets in your calculator. When you do that, what do you get? C. Number 2 uses can be made out of letters of the word engineering. So the whole thing, there's no restrictions, right? Just the word engineering. So E, N, G, I, N, E, E, R, I, N, G. How many letters are in engineering? 11, I believe. 1, 2. Okay. So on the top you have 11 factorial. I don't need to do blanks because there's no restrictions on the word. But could I go 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1? Sure. It's excessive in this case, but you could. In the bottom, you have to go 3 factorial for the E's, 3 factorial for the N's, 2 factorial for the G's. When you do that, which do you get? 8.
Another 2.
And for the I's. Oops. There. And what do you get? B. Number 3 says determine the number of ways in the letters in the word kitchen can be arranged. Kitchen. K, I, T, C, H, E, N. If I just rewrite the word, because nothing doubled or tripled, I don't have a denominator, right? That's the best part about it. So now it says the letters K, C, N must be together. Does it say together at the front, back, middle, anything like that? No, just together in the order K, C, N. 1, 2, 3, 4, 5, 6 has to be in the order K, C, N. So I have 1, 1, 1, and then I have 3 left, 2, 1, and I have to multiply by?
Shipping 4, 3, 2.
So there's 7 letters in kitchen. Who knew? 4, 3, 2, 1, and I have times it by? 5. So it's the same as 5 factorial technically, which is 120. Then it says letters KCN must be together, not necessarily in that order. Sure. 1, 2, 3, 4, 5, 6, 7. KCN not necessarily in that order. So I have how many now? 3 then. Then. You see the multiplication dots? You better have them as well. And then 4, 3, 2, 1 multiplied by 5. Could you use a multiplication symbol there instead of the multiplication X? Yeah, I just prove a point that I'm taking this case 3, 2, 1, 4, 3, 2, 1, and I'm timesing it by 5 because there's 5 cases that look exactly like that if I drew them all out, right? If I move this around. So I get 3 factorial times 5 factorial, which is 720. 4 says, Anne, Brian, Colin, Diane, and Eric, 5 people, go to a movie and sit in 5 adjacent seats, so seats side by side by side. In how many ways can this be done if Brian sits next to Diane? So I sit Brian and Diane next to each other. Does it say Brian has to be on the left and Diane on the right or anything like that? No. So how many options do I have for the first blank? 2 then? Then how many left? Now if it said they had to sit on the far left, we'd be done, correct? But it doesn't say that, so we have to multiply by 4 because they can move here, 2, 3, or 4 more spots, right? So it's actually 4 factorial times 2, or 2 factorial, which is the same thing. So you get 48. Now Anne refuses to sit next to Eric. He's smelly. I don't know why she just refuses to sit next to him. So we have 1, 2, 3, 4, 5. So we do total no restrictions, which is 5 times 4 times 3 times 2 times 1, which is 5 factorial, which is 120. There are 120 different ways that these people could just sit anywhere, right? That's the total number of ways. There's no more, no less. No. It was worth a try. Then you have to subtract the ways that Anne sits next to Eric, which is actually the same amount as this one, right? 2, 1, 3, 2, 1 times 4. So we subtract off 48 from 120 and we get 72. All right. Then we have determine the number of ways the letters in the word anteater. A, N, T, E, A, T, E, R can be arranged. I don't even care what it asks me at this point. I'm going to go 2 factorial, 2 factorial, 2 factorial, right? Then I go to the question, because no matter what, I'm going to divide by those factorials every single time. The word begins with a consonant and ends in a vowel. Anteater has 3, 6, 7, 8. So it begins with a consonant. How many consonants are there? 4. So I have 4 options. It ends in a vowel. How many options?
4.
How many letters have I set down? 2. How many do I have left? 6, 5, 4, 3, 2, 1. So I technically have 16, because of the 4 and the 4, times 6 factorial, in brackets, divided by 2 factorial, 2 factorial, 2 factorial, or 2 times 2 times 2, which is 8. And what do I get for an answer? 1,440. Now it says the consonants must be together. 2 factorial, 2 factorial, 2 factorial. That's not changing. 1, 2, 3, 4, 5, 6, 7, 8. The consonants have to be together. 4, 3, 2, 1. How many are left? 4, 3, 2, 1. Does it say that they have to be together at the front? No. So we have to times it by 5, because we get 5 more scenarios of this exact same scenario. So we actually have 4 factorial, 5 factorial in brackets, divided by 2 factorial, 2 factorial, 2 factorial, which is 360?
Yes.
And then the word must begin with the T's, all the T's. How many T's are there? 2. 1, 2, 3, 4, 5, 6, 7, 8 must begin with the T's. So I have 2, then 1. People will say I can't tell them apart. Doesn't matter. The T's, the problem gets rid of down here, right? Like I don't have to worry about it. I treat them like they're different up top. Then I have 6, 5, 4, 3, 2, 1. Do I times it by 7? No, because it says begin. And sometimes you'll see throughout my notes, hopefully they're all fixed, it says being, because it'll like autocorrect me from begin to being, which is not, I'm like, that's not what I want, but thank you for helping me out. So we get 2 factorial, 6 factorial. I'm just going to show you what they can do as an answer. They can do this as well. Because they're multiplied, all multiplied, those can cancel, so they might give you the answer of 6 factorial over 2 times 2, or 2 factorial over 6 factorial over 4. They might give you something like that. Because these cancel off, even though they actually did exist. So don't let it throw you off. 720 divided by 4 is 180. And then the A's can't be together. So I do all the words in anteater, no restrictions. How many letters are in anteater? 8, but I have to divide by 2 factorial, 2 factorial, 2 factorial, which I believe is 5,040. And then minus, now the A's together, right? And there's 2 A's. So I go 2 times 1 times 6 times 5 times 4 times 3 times 2 times 1 times 7 over 2 factorial, 2 factorial, 2 factorial, which is actually the same answer. Did I do that one? No, I never did. And what do we get? Minus what?
Minus 1,560.
What's our answer?
3,780.
80? Now we're moving on to combinations, which is the Yep, notes in front of your face that I just handed out. Or on the bottom half of them. So combinations, order doesn't matter, and we need to figure out what's a combination and what's a permutation, so we're going to go through them. We have combinations to go through today, and then we have at least and at most cases of combinations to go through tomorrow. Then we're done the whole unit. Then we move on to probability, and we keep reviewing these. And then your unit test is on perms and comms and probability. So we're halfway down the sheet. We're on here. It's combinations. So we've discussed these already. Combinations is a selection of elements in which the order of the order of the section is not taken into account. The order of the selection, maybe? That's what I'm supposed to say. I don't know. That's a typo. Determine when order matters. Okay, so in these two, you're going to tell me when order matters. A committee of 9 people chooses 3 people to be the president, vice president, and secretary. Or a committee of 9 people chooses 3 people to form a subcommittee. 3-person subcommittee. Which one of these is a permutation? Which one of these is a combination? Which one does the order matter? Which one does the order not matter? Yeah. Your reasoning actually makes you do the opposite, which is correct. So a committee of 9 people chooses 3 people to form a 3-person subcommittee. That's random. Your 3-person subcommittee is completely random, right? If you're picked first, second, or third for that subcommittee, is anything different in your life? Nope. So this is a combination. The first one has jobs. The moment you give something jobs, it's a permutation. Order matters. Different jobs. If you give them all the same job, like you said, hey, I'm picking 9 people to form a committee and all 3 of them are secretaries, then it wouldn't matter because they all have the same job, right? Or like you pick 3 prizes and they all have the same prize, right? That would be the same. But if you give them 3 different prizes, then order matters, it's a permutation. Here we gave them 3 different jobs, so order matters, it's a permutation. So here we have the formula for combination. Now the formula for permutation, these are both on your formula sheet. The formula for permutation, NPR, is n factorial over n minus r factorial. We agree? That was the formula I gave you. If you look, what's the difference between NCR and NPR? The combination formula and the permutation formula. What's the only difference? Bless you. Sorry? Yeah, you're dividing by r factorial. When we divide by something factorial on the bottom, why do we do that? We've been doing that. Why did we do that? Yeah. It's getting rid of what? Why do we do the factorial on the bottom? When have we been dividing by factorials? Getting rid of repetitions, correct? Getting rid of the repetitions. So why would I do the permutation formula and divide by r factorial to get the combination formula? Combination order doesn't matter, correct? So if I take the permutation formula where order matters and I divide off all the cases that are this different, what am I left with? Where order doesn't matter. It gets rid of all of the order mattering cases. That r factorial on the bottom gets rid of all the cases where the order matters. So like if I did a 9-person, right? 9-person and I picked a 3-person subcommittee, I'd go 9C3, correct? And that would be my combination. If I did it where I picked the actual president, vice president, secretary, I'd do 9P3, which would give me more cases because I would be ordering them, correct? But if I take that answer and I divide it by the factorial of all the different cases, I would be left with no cases. Like all the different cases would be gone, where order matters would be gone. So this r factorial just gets rid of those repetitions. It gets rid of the actual cases where they look different because they don't look different. We're not ordering them. Something to note, NCR can be written like this. So if I have a 9-person committee and I'm choosing 3 people to be on the subcommittee, I could write it like this. You see that? I could also write it like this. That means NCR. And if you're like, how am I going to remember that? It's crazy. It's on your formula sheet. So it tells it to you. You can only use that for C though. P doesn't have anything fancy like that. People might be like, well, why doesn't it? I have absolutely no idea why. Why C does and why P doesn't. They put it on the formula sheet. That's it. That's all. I have no idea why they didn't put a short form for P, but they do. So, okay. Now this is something I want you to do. Go into your calculator and type in 9C3. Go to your calculator. So you're going to go 9, and then you're going to go to math, and then you're going to go over to probability like we've done the whole time. Instead of picking P, we're going to pick C this time. So 9, math, over to probability. We're going to pick number C. Number C, oh my gosh. Letter C, which is number what? 3. And then put a 3. And then enter. What's 9C3 equal? 84? Okay, what's 9P3 equal? This is the one with like the president, vice president, secretary. Type that in. What's 9P3? Oh, Riley.
I'm doing calculator add.
Why aren't you using the
Problem solve.
You're not a problem solver. A problem solver would say, hey, Mrs. Lepp, can I borrow a calculator? That's what a real problem solver
I
would
have
say.
batteries. I have batteries.
Why do you need that?
Because watching the dinner wrong.
Okay, 9P3 is what? Pardon? 504. Why is it more? Because the order in which I put the people matters, right? So if I pick the 3 people and it was Tom, Sam, and Frank, Tom, Sam, Frank would be different than Frank, Tom, Sam would be different than Tom. Yeah, it would all be different. But if it's a combination, picking Sam, Tom, and Frank and ordering those 3 around wouldn't matter. You're going to still get the 3-person committee. So it takes away all the cases where they look different. Now, this is even more fun. Do this. 9C6. Type that in. 9C6. Same answer, isn't it? This is also fancy, only with C's. This does not work with the P formula at all. This only works with the C formula, and I'll show you why. If you take the difference between these, what is it? Difference is subtraction. 6. What did I do? 9C6, and what did I get? Same answer, didn't I? So what if I gave you 10C2? Put that in your calculator. 10C2. Group of 10, and I'm just choosing 2. What'd you get? 10C what's going to equal 45 then? 8, because 10 minus 2 is 8. Try it out. 10C8. You can see the same answer, doesn't it? The common difference between the two. So instead of giving the answer 9C3 when I'm picking a 3-person subcommittee, they could actually have a multiple choice answer as 9C6. It's the same answer, even though you're only picking a 3-person subcommittee. Let's flip over and see why that happens. Show that 10C4 equals 10C6. We're going to use the formulas to show this. Ready? So I'm going to write here 10C4, and then a space 10C6. I'm going to show how they're the same thing. And I'm going to write above the formula. So it's NCR equals n factorial over n minus r factorial r factorial. And this subtraction thing, this 10C4 equals 10C6, only works with C's. Do not pull this with a P. It does not work. It'll give you a totally different answer. If you went 10P4, 10P6, you will not get the same answer. It only works with C's. Okay? Let's show why. So this is my N. This is my R. Because it's N, R. N always has to be greater than or equal to R. Right? We know that. You can't have like four things and choose 10. That makes no sense. So we're going to fill it into the formula. So we get n factorial. So we're going to get 10 factorial over Then we do 10 minus r factorial. So it's going to be 10 minus 4 factorial. And then we do r factorial, which is 4 factorial. And then we're going to go 10 factorial over, what's 10 minus 4? 6 factorial, 4 factorial, right? We're not getting an answer. That's it. We're going to stop there. Let's try it with the other ones. I'm going to put an equal sign in between. Hopefully these equal. Because it's saying show that they equal. Really hope it's not wrong. We also just proved that it worked with our calculator. So now this is my n and this is my r. So I'm going to go 10 factorial over n minus r, so 10 minus 6 factorial, r factorial, which is 6 factorial. So I'm going to get 10 factorial over 4 factorial, 6 factorial. Are they the same? My one denominator is 6 factorial, 4 factorial. My other denominator is 4 factorial, 6 factorial. How are they the same? They just are. 2 times 3 is 3 times 2, right? If I had, say, a 10-person subcommittee and I was choosing, or 10-person committee and I chose that's going to look stupid, 7-person subcommittee, what could they give me as an answer on the diploma or on the unit test? 10C3. Now, does that make sense? A 10-person committee and I'm picking 7, and then they give me 10C3? It could throw you off if you don't know that they're the same thing, right? They are the same answer, so they could do that. Okay? So here's that little rule. NR is the same as NN minus R because this is the same as NCR equals NC N minus R. If you take the common difference, you use it as variables. So let's look at example 1. A student must sign 3 different books out of the library to read for her English class. She has to take out these 3 books. She has always returned her books on time, so she's allowed to take all 3 books out at once. How many different ways can she sign out the books? So she can go in, get her 3 books, she can take them all out at once and go. So does the order of those 3 books matter? No. So she has how many books? 3, and she's choosing, because the order doesn't matter, it's a combination. How many is she choosing to take out? 3. If you're on your phones, you really, really badly should not be on them, because it's going to go real rough in a few seconds. Okay. Type 3C3 in your calculator. What do you get? 1. Does that make sense? I go into the library. I hand her 3 books. She hands them back to me. I leave. How many ways do I have for that to happen? 1. I go to her. I hand the book. She hands them back to me. I just walk out. 1 option, right? Okay. So we always have to look at this number here and say, does it matter how I take these 3 out? Did it matter how I took these 3 out? In this case, nope. Okay, let's look here. Another student must sign 3 different books out of the library to read for her English class. She is bad standing with the library and can only take 1 book out at once. So does the order in which she picks these 3 matter? Yes, because she gets whatever book first, then the next 2, then the next 2. So it would be 3 what? P3. Or I could go, first month she gets 3 options, second month she gets 2 options, last month she gets 1. Because remember 3P3 is the same as 3 times, right? Same 3 blanks. We went through this before. Start with this number. This is how many blanks there are when it's a P. And what do we get? 6. What's up, McLemmon? Dead? Like frozen?
It's saying your battery is low, charging the battery is recommended. You have no calculator.
There we go. I was waiting for the question to follow the whole, like, my calculator is dead statement.
I didn't know if it actually like dying.
Yeah, those have to be charged.
I don't even know what the charging port is at the moment.
I don't think you've been using it a lot. I think I actually. Okay. Example 2. 3 students from a class of 10 are to be chosen to go on a school trip. In how many ways can they be selected? Those 3 going on the trip, is there anything crazy about them? Anything different? You pick first, second, or third, does life change? Nope. So is it permutation or combination? It's a combination. When order doesn't matter, it's a combination. So how many do we have to choose from? 10. C, because it's a combination, how many are we choosing? 3. Which is actually the same as 10C what? 10C7, which could also be written as 10.3, which could also be written as 10.7. Why are there so many options? I have no idea, but there are. Type 1 in. Don't type all 4. That would just be excessive. That's the same thing. So go 10C3. What'd you get? 1 what? 120? Did everyone get that? Okay. So it should be smaller than if it was a permutation, right? Because order would matter. This one, we have 3 students from a class of 10 are to be chosen to go on a school trip. The first gets to go to Germany, the second gets to go to Toronto, and the third gets to go to Walmart and Okotoks. How many ways can the students be selected? Does the order in which you pick first, second, or third matter? Yeah, because maybe you really want to go to Walmart, right? So, how many options do we have? 10, and it's a what? Permutation, and how many are you picking? 3. Now remember, when it's a permutation, that's the same as saying, okay, I'm starting with the number 10, and how many blanks am I using? 3, and I have to go down by 1 each time. So both of these should be 720. And the moment you're using blanks, you're ordering them. You're putting them in an order. So if it's a combination question, do not use blanks. That would be silly. You'd be ordering them. Okay, flip over. To win the Lotto 649, a person must correctly select 6 numbers. It doesn't have to be in, like, from 1 to 49. That's why it's Lotto 649. You're picking 6 of 49 numbers. The order in which they get picked does not matter. It would be insane. If you actually had to not only get the 6 correct numbers and you had to get them in the way that the order that they were picked, the Lotto would never happen. It's like hard enough as it is. It's a combination. The Lotto is a combination. You just have to have the same 6 numbers, right? They don't have to pop up like out of a machine in the exact same order. Yeah, you've gone twice and you haven't got to go yet once. This is like a default. Look at that. That's the problem. You're going to miss out on stuff which you wouldn't want to. Now he's filling 2 water bottles. Smart boy. Didn't go. Sent his water bottle with. Look at you. Okay. 6 numbers. 1, 2, 3, 4, 5, 6. Jasper selected the 6 numbers for his birthdays of his family. 3, 7, 9, 11, 20, 29. How many different selections of numbers could he have made? So he made 1 selection. It was 3, 7, 9, 11, 20, 29, which is going to be, that's actually more important for probability, which we're not asking. They just want to know how many different combinations could he have had. Can I do blanks if it's a combination? Can I do blanks if it's a combination? No, I'm ordering these. This is permutation, isn't it? So I can't do that. How many numbers do I have to choose from? 49, and it's a combination, so I put a C. How many am I choosing? 6. Type that in. 49C6. It's still a big number. Maya, what'd you get?
139 H3H16.
So you have a 1 in 13,983,816 chance of winning the lotto. Now people will say, okay, well if 13,983,816 people buy a lotto, we should all win. One should win, not all win. That makes no sense. So I'm just going to get one person. Is that the case? No, because people can actually do what? They can pick the same numbers, right? There's some people who will, like sometimes no one picks the correct numbers. Sometimes 10 people do, and then they have to split the lotto, right? So you can't just go based on 3 million. You'd have to like literally have a good old scheme, and you'd all have to like literally work together and pick out the 13,983,816 different choices and work together with 13,983,816 people and do it. Now, keeping in mind that if you did do that, you'd have to go buy all those tickets. It would take all that time, and probably you would actually spend more than what the lotto was, I would say. Because it would have to be over 13 million. times like, I don't even know how much a ticket is. I know like almost like 4 plays, like 20 some bucks. I only know that because I go in and I'm like, hey, help me. Because I don't do lottos very
They
often.
charge $24 for 4 plays.
Yes, it's like 21 bucks or something. I don't know, it's 20 something. Right? So it would say it would be like $5 a play. Well, you'd need to have 13 million times $5. Your lotto millions has to be a lot of millions in order for it to be worth itself, which it's not. Okay? Yeah. Yeah. Okay, this one. Actually, we're going to go here. Go ahead. We'll come back to those ones. I want you guys to go, sorry. Example 5, do the your turns. So I want you to do number 1 of the your turn, number 2 of the your turn, it's 2 pages ahead. Number 3, actually skip number 3 for now. You're going to do it, don't cross it out, you're just not going to do it right now. 1 and 2 and 4. 1, 2, and 4. Try those ones out. 1, 2, and 4. So here it says, Pete's Perfect Pizza Company has 9 choices of toppings available. How many different 2-topping pizzas can be made? Does the order of those 2 toppings matter? You put cheese and pepperoni, or pepperonis and cheese. You might be like, yes, it's very different. Still a cheese pizza, right? So pizza, chili, stuff like that, all the same. So we would do 9C2, which is the same as 9C what? 7, which is the same as 9-2, which is the same as 9-7, which is the same as what answer? Pardon? 36? Okay. You were all whispering it and at different rates. So I'm just hearing sound like a snake was in here. That's all I had. So I knew there was a 6 somewhere in the answer. All right. Now how many 3-topping pizzas? Well, it would be 9C6. Which is the same as 9C3, because the difference, which is the same as 9-6. Do you have to list every single one of these? No, I'm just proving a point. What's the answer? 84? Ah, we got more options, which makes sense, because we have more topping options, right? So we're going to get more pizza options. Now, a theater company consists of 6 players to be chosen from 15 actors. How many selections are possible if the company must include Mrs. Jones? So we're picking 6 people from 15 actors, correct? But we have to have who? Mrs. Jones. Okay, so I'm going to choose her first because she's my restriction. So how do I choose Mrs. Jones? Okay, I need Mrs. Jones. And I choose Mrs. Jones. Done. Isn't that amazing? I have one Mrs. Jones and I choose her. Ha! So that's one way. So now I chose Mrs. Jones. Now I need to choose the rest of the people. Do they have specific jobs in this acting position or anything? No, they're all just like background people or something. So I need Mrs. Jones. And that's how I chose her. And multiply. I need to choose now what? 5 players. Right? I need Mrs. Jones. I take Mrs. Jones, I choose Mrs. Jones. Boom. And I need to have 5 players. So I know I'm going to choose 5 players. How many am I choosing from? 14. Why would I choose 14 and not 15? Because I already had one. Mrs. Jones, she's already picked. So she's still out of the 15. So now I have 14. Boom, boom. 1 choose 1 is 1. I go, hey, Mrs. Jones, come here. 1 way. And then I have 14 left, and I choose 5. So not only did I have to go down 1 in numbers of players, I had to go down 1 in numbers of people originally, right? So what do you get for that? How much? 2002? It was a great year. It's the year after I graduated high school. You were born. It's fine. Mold. Okay. Number 3, we're going to skip for now. Number 4, Holy Trinity Academy has 12-member student council. Yay! A 4-member subcommittee is to be selected to organize dances. How many different subcommittees? Do those subcommittees have any jobs? Did they? Did it say they did? On here? Does it say anywhere they have jobs? Specific jobs? No. If they don't have specific jobs, is it a permutation or a combination? Combination. It's a permutation if I pick a 4-person subcommittee and 1 is the planner, 2 is the principal, I don't know why I said that, president, 3 is the vice president, and the 4th one is the treasurer. Then I'm giving them specific jobs. Specific jobs for the 4 people, P. Not specific jobs, C. So how many do I have? 12. C, because it's just 4 people on a subcommittee, they don't have jobs. 4. So what's 12C for? C4. Okay. Now, B throws people off. I put this one specifically because people see jobs and they start thinking it's permutation. It says how many subcommittees are possible if the student council president and vice president have to be on the subcommittee? President and the vice president have to be on the subcommittee. Did I give the subcommittee those 4 people jobs? No. I just said the president and vice president, just like Mrs. Jones and Tommy or something, have to be on the subcommittee. So how do I guarantee the subcommittee is 4 people? The subcommittee does not have jobs. It hasn't changed. I just need to have the president, and I need the vice president, and I still need what? 2 other people to form this subcommittee. This subcommittee still, does it have jobs? Does this subcommittee have jobs yet? No, it's a 4-person subcommittee. There's no jobs. People will be like, but the president, the vice president, that's not jobs on the subcommittee. Those are the people who are on the actual student council. So how do I guarantee getting the president? There's 1 president, and I choose them. It's crazy. And multiplication. How do I guarantee getting the vice president? There's 1 vice president, and I choose them. And how do I guarantee getting the 2 others? How many am I going to choose from? 10, not 12, because how many people have I chosen already? 2. I took the president out. I took the vice president out. Now I have 10 left of these people to choose 2. So that's 1 times whatever the heck 10 choose 2 is. What's 10C2? 45? So it would just be 45. And if this is a written response, you write it in a sentence, just so you know. That's it.